So I'm assuming that some of you have probably already worked on A2Ls. Anybody here know if you've already worked on R32 or 434B? Anyone know? No? So did anyone do the install of the Daikin unit that's up here, that one there? There was a ductless unit that I think you installed at my house. No, who did the ductless at my house? That was you. Yeah, the ductless. And then there's another ductless in the back of the building over here. So those were all already A2L refrigerants. So some of you have already worked on that, so I'm a little late on the class here, I guess. The first thing that I want to start with is just this transition is nothing like what we faced when we went from R22 to 410A. So was anybody around for that? Were you around for that? Okay. You weren't actually around for when we started the transition. Like
when we first, oh yeah, it was already introduced.
It was already introduced, yeah.
Of the phase out.
Okay, so when we first went from R410 or R22 to R410A, I mean, you would have thought that it was a cataclysmic event because we changed oils. The pressures went up by a significant amount. For any of you who have done service on R22, the pressures are significantly lower. And so, I mean, you would have just thought that basically the industry was ending. This is not going to be that kind of transition. And so much so that some of you have already worked on A2Ls and didn't even know that there was anything really that different about them because the pressures are about the same. The oils are the same. There's not a significant difference in the way that the equipment operates. The significant difference comes in the fact that it is a mildly flammable refrigerant. So let's walk through that. So what's happening to 410A? We'll just start there. First off, it's a phase down, not a phase out. It's a reduction of 85% by 2036, which is a really long time. But that doesn't change the fact that they are banning the manufacturing of light commercial and residential R410A equipment starting at the beginning of next year, which means that you're not going to see 410A in new equipment starting at the beginning of next year. And that does not mean that they're banning it on individual parts. And this is where it gets kind of tricky because what does the EPA consider to be, or not just the EPA, but all the different regulatory bodies, what do they consider to be a part or a component? What do they consider to be a system? Well, on a split system, historically, they haven't considered either side to be a system. It's the combined system, okay? So there will be some, at least my current understanding is that there will be some R410A condensers that you can buy, and there will be some R410A air handlers that you can buy, but you're not allowed to put them together into a system, I guess. And package units and that sort of thing will not be available. They can be installed through January 1st, 2026, and that was actually a new change. Initially, they weren't going to let us do that, but they extended it another year. Actually, the HVAC school and a couple other folks wrote letters to the EPA, and they were very responsive to that. In fact, the EPA was actually watching one of our live streams that we did. They were literally in the comments. When you do a live stream and you see the people live commenting, it literally said EPA, and their comment was, "We're listening to your feedback," which we all thought was a little creepy. Like maybe they were gonna, I don't know. I don't know what that meant. But anyway, the point is that they did listen to that, and that wasn't originally they were going to ban what they call the sell-through date was going to be the same as the manufacturer ban, which is going to be a real problem because if we had any 410A equipment in the warehouse, we weren't going to be able to sell it. So they gave us an additional year on that sell-through, which was a good thing. You don't have to memorize any of this, thank heavens. The point is there's just going to be this consistent phase down where EPA is going to just consistently reduce the amount of new 410A that can be produced, which means the price is going to keep going up over time. The same thing we saw with R22. Now there's a point at which it kind of stabilizes because it actually becomes less common and less needed, and so it will eventually stabilize. But the price of 410A is going to go up. We do need to recover it. Recovered stock is really, really important on 410A. Obviously, we take that very seriously here. But if any of you aren't, you need to take it very seriously. One of the things that this does affect, and we're going to talk about this, though, is the importance of us keeping really good track of what we are recovering. So keeping really good notes on how much we pull out of pieces of equipment, and ensuring that that all does get returned. So to any extent that there's a question about how we're doing that, we need to make sure that we're being really, really consistent about that and keeping really good records on that. In the past, whenever a system had less than 50 pounds of refrigerant, there was no ban on recharging leaking equipment. Okay, so if it had less than 50 pounds of refrigerant, there was no ban. They're actually changing that now, where there are leak repair requirements. We're not going to go over what they are, but there are leak repair requirements for equipment in between 15 and 50 pounds starting in October of this year, which means that we are actually going to have to start paying attention to leak rate requirements, where in the past we never used to have to. One of the things that comes up, and I think this is one of the other slides, but I just want to bring this up. Whenever people would say things like, well, R22 is banned, you can't use R22 anymore, we know that that's not the case, right? We still have tanks of R22, we still recharge equipment with R22 in it. But one of the things that changed a lot was, in the past we talked about ODP. Does anybody remember from your EPA exam what ODP is? Anyone? I know this is kind of stuff you forget pretty quickly. Ozone depletion potential, right? Yeah, those of you studying for it right now, you know what it is, right? ODP, ozone depletion potential. That was what we used to care about with refrigerants, and so with R22 had a little bit of ozone depletion potential, which is literally the ability for the molecule to make holes in the ozone. Nowadays, we're not talking about ozone depletion potential. That's not even in the conversation. So when we went from R22, which had this infinitesimal ozone depletion potential, to R410A, we actually got a refrigerant that had a little less ozone depletion potential, but actually had higher GWP. Does anybody remember GWP from your EPA? Global warming potential. Okay, now we're not talking politics here, and I'm not going to render any opinions. I'm just telling you the words and what they mean and what they say it is. Okay, but the global warming potential of R410A is actually higher than that of R22. So we got a refrigerant that was slightly, went from a very small number to a zero number on ozone depletion potential, but we got a refrigerant that had a higher GWP. So we kind of always knew, as soon as GWP became a thing, that we were going to have to reduce that. And so this is why even now recovery is very important in the legal code, and also that's why they're extending this leak repair protocol for equipment that has even lower refrigerant charges. So one of the things that's going to become important, and we're going to add this into our software as this starts to evolve, is going to be actually keeping track of any time that we add refrigerant to a system. And then also keeping track of what the refrigerant in the system is, so that you can look at that fraction. What percentage of refrigerant got lost over that period of time? That's actually going to become important. In the past, didn't matter, because in residential we never had more than 50 pounds. Now, we do have systems that have more than 15 pounds. Not that common, but it can happen. And again, I like to bring this up just because, so this is a little political, I guess, but just to remind people that literally we banned R22 because it had a 0.055 ozone depletion potential, which I don't remember what R12 was, but R12 had like a significant number ozone depletion potential. So R22 already had almost no ozone depletion potential. It didn't really deplete the ozone very much at all. It's more than zero, but it wasn't a lot. And we replaced it with R410A, a high pressure refrigerant, a more challenging refrigerant for us, with an actual higher global warming potential, which is kind of annoying. But now we have this requirement to reduce high GWP refrigerants again. Now, does anybody kind of remember what we do in order to make refrigerants, or what they do with the chemistry in order to give it a lower GWP? Does anybody know? So what they do is they create a more unstable molecule, right? In order for something to have a high GWP, means that it has to remain stable as it actually makes it up into the atmosphere. And so what they do in order to make something have a lower GWP, generally speaking, is they make it a more unstable molecule. So that way it breaks apart before it makes it into the atmosphere. One of the things that tends to happen with more unstable molecules is they tend to be flammable. It kind of goes hand in hand. And the term is reactive. It tends to be a more reactive molecule. More reactive molecules also tend to be flammable molecules. And this is true pretty much across the board, and which is why now, in order for us to have these more reactive molecules, we also tend to have them be flammable. And so that's what matters now. When we're working with these A2Ls, we're dealing with a slightly flammable molecule. All right, just a quick brush up on this, on the ASHRAE refrigerant classification system. This just kind of talks about toxicity and flammability. So the A means that it is non-toxic, B means that it's toxic, okay? We don't work with any toxic refrigerants at all in what we do. The one that you would be most likely to bump into that would be toxic would be ammonia. And it'd be very, very rare. It's like if you went to a skating rink or something, you would see ammonia. Or if you were dealing with process refrigeration, you might see ammonia. But you will see flammable refrigerants. One of the most common flammable refrigerants is propane. In fact, you could take an old R22 system, you could actually charge it with propane. I'm not telling you to do this, and I probably shouldn't even be saying this, but you could charge it with propane, and it would work better than it did with R22 in it. Propane is an amazing refrigerant. It's one of the best refrigerants there is, and it has very similar properties and pressures to R22. So it's a lower pressure refrigerant. It's really good. This is not propane. Okay, so you all deal with propane. You know how propane lights. You've lit a gas grill before, right? Are you afraid? Are you like shaking in your boots every time you have to light your grill? Are you terrified? Are you terrified every time you go into a house that has gas piping in it, natural gas or propane? Just terrified, shaking. Josh is a little bit? Always a little bit. Well, just a little bit? Okay, that's good. No, that's fine. It's no judgment here. But I'm not trying to downplay the safety element of this because it is very important. But I am trying to tell you that there's nothing to be afraid of, okay? Because A3, which is the highest flammability, that's propane. Propane is basically the highest flammability refrigerant we're ever going to work with. And we're not afraid of propane right now. Now, I'm going to talk about some things that do make it a little bit more risky, but we're not afraid of it. What we're dealing with today is an A2L, which is not even an A2 refrigerant. It is a mildly flammable. So it used to be A1, which was no flammability, A2, which was low flammability, and A3, which is higher flammability. Now we have this A2L, which is basically just to say it's only slightly more flammable than what you already have. Now, this is where questions come up. Well, but 410A isn't flammable at all, right? Who would agree with that? 410A is not flammable, right? Actually wrong. 410A is actually flammable. In the sense that, now again, words are tricky. So ASHRAE says that it is not flammable or no flame propagation. But the reality is if you have a house fire or you expose 410A to an open flame, if you've ever kind of seen when you're unbrazing something, if you're unsweating something and you get that poof, that's actually 410A burning. It does burn. It just doesn't have flame propagation that's high enough that they designate it as flammable. And so what they realized is they had a problem. They created this test standard, this ANSI standard, and within this standard, they said this is the line, and if you go over this line, it's flammable. If you're under this line, it's not flammable. And they came out with a couple of these refrigerants that were just slightly over the line, but they were better refrigerants in the sense that they had lower GWP. But in some ways, they were actually better refrigerants, and we'll talk about that. And so they said, crap, like we've got all these fire codes throughout the United States. We've got all these things. How are we going to solve this problem? Because we want to use this slightly more flammable refrigerant. And so they just made up a new thing. That's how they got around it. Rather than rewriting all the codes, they're like, no, this isn't an A2. This is an A2L, right? You should try this in like your personal relationships and stuff at some point. Just change the meanings of words and see what happens. My wife doesn't dig it, usually. All right, so this just gives you an indication. This picture is like hard to even understand what's happening. But it's actually just a flame. So they're actually burning it. And if you can see, in order for it to be a class 1, it has to stay within the cone. And if it goes outside the cone, it's no longer a class 1. And that's literally the difference we're talking about here. It's kind of silly. So anyone who gets all freaky, because there is, and if you go on social media, and I mean, social media is social media, so it's always nutty. Everybody's like, oh my gosh, our vans are going to be exploding. We're going to have, watch these videos from India where people are blowing themselves up. It's going to be just like that. Nobody cares about our safety. This is so dangerous. Look, it is something to pay attention to. It is something we need to be safe, but it's nothing that's really that much different than what we've already been facing. And it's certainly nothing like propane. So when you work with these refrigerants, you're going to hear some people, if you go to supply houses or you talk to your friends in the trade or whatever, they're going to say, this new refrigerant has propane in it. People say that all the time. It does not have propane in it. It is not propane. It's nothing like it. It's just a slightly more reactive refrigerant that allows it to destabilize before it makes it into the atmosphere. Okay, does that make sense? So that's the important message. It's an important message so that you're not afraid. Versus higher flammability, and that's what propane looks like when it was ignited in the same test. It's like a nuclear bomb compared to what we were seeing before, right? And again, we know what propane is like when you light it, right? We know what gasoline is like when you light it. I mean, at least if you grew up the way I did, you know what it is like. It's very flammable. It's something you have to take really seriously. Either way, take it seriously, but don't be afraid. All right, two different refrigerants that you're going to be seeing. So if you're working on Daikin equipment, specifically, you're going to see R32. Now, R32 has one significant challenge, and that is that it doesn't do quite as well in high ambient conditions. So when it gets real hot outside, it doesn't do quite as well. So in places like Arizona, where it gets to be 120-degree outdoor temperatures and you're condensing, it doesn't do quite as well. But it actually has a little better performance. It's a single component refrigerant, meaning it has no glide. So the fancy word for that is azeotropic, if you remember that from EPA. It's a single component refrigerant. So that's kind of nice. Now here's the other cool thing about R32 is that you've already been working with R32 this whole time, because 410A is 50% R32. It's 50% R32 and 50% R125, which always brings up the thought in my head. It's like, imagine this engineer, okay, who's designing 410A. He's like, let's try 50-50. He tries, he's like, that works, and he just stopped there. That's all I can imagine. Like, literally, do you really think that 50-50 was the exact right mix? They tried 49-51, and it just wasn't quite right. Anyway, that's a stupid joke, but it just always made me think, like, 50-50, really? That's odd. And 410A is half R32, half R125, and R125 is basically, it's kind of like a fire suppressant. So they took 32, they added 125 to it in order to get the flammability down, so that way it could be used. So essentially, R32 is like R410A, I don't know, with the top taken off. Basically, it's really more capable refrigerant. It has better latent heat vaporization, which is the main thing that kind of dictates the effectiveness of a refrigerant. So it's a better refrigerant in a lot of ways than R410A. It basically took the limiter off. It works a little bit better. So it's a good refrigerant. That's the point. And it's a single component. All right, R454B, the first thing you're going to notice, I'm going to kind of go back. The first thing you're going to notice is the GWP. Okay, so GWP on R32 is 675. Which is just below the targets they're trying to hit. R454B is a GWP of 466. And that's the main reason why Carrier and a lot of other manufacturers went to 454B, is because they're trying to get a lower number so that way they kind of beat future phase outs. They're trying to kind of get ahead of it. Or 454B is what they call an HFO blend. So it's a slightly different refrigerant. It has several different refrigerants in it. One of the refrigerants that it has in it is actually the one that they use in cars, which is, what is it, YF1234, which they call it YF1234, but it's literally 1234. I mean, come on. And they've been using that in cars for years. So anybody who's also freaky about A2L is like, oh my gosh, do you know? This is an explosive refrigerant, it's going to kill you. Well, you've been driving around a car with it for years now. And by the way, anytime you go to a grocery store or you touch a vending machine and you get a Pepsi, that probably already has propane in it. So there's flammable refrigerants all over the place. We just don't work on them in residential. That's all. It's nothing really that new. You'll also notice that it has a little bit of glide. Just a little bit, but it's enough that you actually have to account for it. So if you remember about glide, that means that you use a different number for subcooling than you do for superheat. So it's that dew point and bubble point thing. So you use dew point for superheat and you use bubble point for subcool. The way to remember that is bubcool and duper heat. Literally, that's how I still remember it. And everybody who teaches it remembers it that way. So you use bubble point for subcool, and you use dew point for superheat. But again, if you're using an app or something like that, it'll do the math for you. You don't even have to, just make sure you're using the right refrigerant in the app. You'll also notice that there's a slightly different oil weight. Now, that's not something you're going to have to care about generally speaking, but if you ever had to adjust an oil charge or whatever, it is a slightly different weight of oil. Still POE, but it's a different weight. Anybody getting bored yet? It's just stuff you need to know. All right, so similarities, equipment capacity, coefficient of performance, thermodynamic properties, suction and discharge pressure. It's all very similar. R32 does have higher discharge temperatures, and that's what I was mentioning. It runs a little hotter. That's the easy way of saying it. And so coming right out of the compressor, it's a little hotter. And so it actually does have some challenges at really, really high condensing temperatures. But R410A did too, right? That's where we really saw an impact with 410A going from R22 was in really, really hot markets. That's where a challenge did show up. All right, so what's different? So lower GWP, that's the reason why we're doing it. The recovery cylinder looks different. The charging tanks look different. And we'll talk a little bit about that. Cylinder pressure relief. So one of the things about the cylinders when they get shipped, the old cylinders just had a disc in them, and the disc would burst if they ever overpressurized. Anybody ever had that happen? Have a disc burst on you? You have? Really? Under why did that happen? Do you know? Just really hot in the van?
Recently, the last one was a faulty tank.
Oh, okay. Yeah, I guess it could be. Sure. I've never had it happen. So never seen it happen, never had it happen. But that's how it works, is that thing bursts and then it just vents the whole thing. Well, with a A2L refrigerant, because they're worried about the flammability, they actually have a resetting disc. So it will vent until the pressure drops and then it will reset. So it's actually a spring activated little disc, which just makes the tanks a little more expensive. So that goes into the cost of the refrigerant. One of the other things is threads. And this is, the tanks will come with reverse threads. Did you guys already know this? Okay. Man, that's a bummer. Like, why am I even giving a class? Everybody already knows this stuff. That was my big reveal. So you're going to need to have adapters for the tanks. Have you run into this with the tanks already? Have you seen this? Okay. So you're going to have, and that's the only place as far as I understand, I think that's the only place you're going to see it. I don't believe that equipment manufacturers are going to have reverse threads on the equipment. They just don't want you to accidentally put this refrigerant in a system that doesn't need this refrigerant. That's what they're trying to prevent. But again, like, all you have is just a little adapter and pretty simple. So we're going to have to get a bunch of those. They're already made, not a big deal. Vacuum pumps and recovery machines should be A2L compliant. That is a very vague term, and it really isn't, it's not a big deal because almost every machine we already have is already A2L compliant, or A2L compatible is the term that they use. If you're ever in doubt, you can look up the model number with the manufacturer, and it'll tell you if it's back compatible. And we will do that as this starts to evolve and we start to see these show up in the field. Systems are going to have some additional accessories. The biggest one that systems are going to have, one of the first you're going to notice is they have these big old stickers all over the place. They just have stickers and stickers on top of stickers. They just love stickers. It's like a sticker factory. My daughters would love these things. They have big old red stickers all over them. So you'll know when it's an A2L piece of equipment. Yeah, all that. But one of the big things in the equipment is they're going to have leak detection built into the air handler. Or if it's a package unit, it's going to be built in. Now, this leak detection isn't like, because I saw Bert's face at least. He's like, what? Leak detection? Tell me more. It's not going to be like, no, that's exactly how you look. That's really no, that was totally it. Stop. No. It's not going to be a really fine leak detection like we do. It's looking for big events, like you have a lot of refrigerant. And so it actually uses an infrared sensor, similar to some of you use infrared sensors already, just to say, hey, we've got a lot of refrigerant in the cabinet. And then what does it do? All it does is shut the equipment down, meaning the condenser can't run, which I've always wondered because then that's actually going to increase the leak rate. But I think the people who make these codes don't know how air conditioners work. And then it just turns the blower on. That's all it does. Just shuts off the system, turns the blower on. And you may think, well, why would it turn the blower on? Because you want to circulate this all through the house? Well, there's this thing called the LFL. They love 3-letter, 4-letter things in this world. They just love it. They just want any excuse to come up with it. LFL means lower flammability limit. So there's a concentration point at which, under that concentration point, it's not flammable. It won't burn. It has to have a certain acceptable concentration. There's also a higher flammability limit where you get too much concentration and it won't burn. So they're trying to prevent it from hitting that LFL. And so if you run air over it and you mix it with the whole house, because it's a limited source, right? An air conditioner is not like a propane line with a gigantic tank or a natural gas line that's unending. And so they do the calculations, and basically it comes up to there ain't no house that we're going to be working in that it's going to be flammable if it's mixed in with the house. It's only going to be flammable if it sits in the cabinet and is allowed to concentrate inside the cabinet. So that's what they do. And that's called a mitigation strategy. So they're just mitigating it by running the blower. What do you need to know about that? Nothing other than the fact that you're going to see it show up. And the odds that it's going to be a problem, at least early on, are going to be next to nothing. So for installers, it's not going to be a thing. It's going to be built into the equipment. As far as I understand, it's nothing you're going to have to worry about. We don't know all the details. We don't know how it's going to look. I can't show you a picture of it because, again, we're not seeing it out in the wild yet. Best practices, things that we talked about as like, hey, these are should-dos, and these have always been necessary at Kalos. Like we've always talked about, well, I would say always. In the last 8 years, it's been something that we've really pushed. But it's the stuff you're already doing, the stuff we're already pushing. Purge and flow nitrogen. You'd never, ever, and it's going to talk about this in a second, but the biggest risk that you would have is if you're putting an open flame on a tube that has refrigerant in it. And why would you do that? Well, the only reason you would do it is if you're trying to unsweat something. So just don't unsweat things. You know, is unsweat like is that making me sound like a really old person? Do you even say that anymore? You say that. Okay, good. Whew. Just making sure. What do the kids say nowadays for taking the fire and putting it on the pipe and pulling it apart? I don't know what kids say today. That was my old man voice. I don't know if you caught on. That's what I was trying to do there. So you don't want to do that. You want to cut things out. You don't want to unsweat them. So if you're taking a dryer out, you don't want to unsweat. You don't want to unsweat the dryer. You don't want to heat it and try to pull it apart. You just want to cut it out. And sometimes that's a pain in the butt to do. But with an A2L, you really just need to do that. That is one of the biggest things. The next thing is if you're working on a system that previously had refrigerant in it, you want to make sure to purge nitrogen through it first. Just get any of that residual refrigerant out. You have to do a really good evacuation, flow nitrogen while brazing. It's the stuff you've always done, right? None of this is anything new. We've always taken this pretty seriously. All right, so I'm just going to show you a few of these things. And again, you're going to find out really quickly as we talk about all this stuff. I basically gave you the highlights already, and I'm just going to talk through some of it a little bit more. There's nothing that exciting that's going to happen here. But I'll also give a little time at the end for questions if you have any, because you guys always have questions, always. So this is the only difference with the tanks that you're going to notice. You're going to notice that they pretty much all become the same color. Everything's kind of going to become gray, this grayish color. And so you're just going to have to look at I think they just ran out of colors or something, I don't know. But then you're going to notice that this blow-off valve is actually spring activated. You can carry legally up to 440 pounds of refrigerant in your truck, which is the same as it always was. There always was a limit. Nowadays, we're going to try to pay a little more attention to that. I don't know why you would have that much refrigerant in residential on your truck, but I don't feel like, yeah. But I was taking this to the pawn shop. Yeah, no, that's a problem anyway, right? Yeah, that's not allowed. So with A1 refrigerants, it's gray tank with a yellow top. A2L recovery tanks are going to have a big old red stripe on them because it looks cool. That's the reason why it says that right in the code, that it looks cool. A2Ls have to be recovered, can't be vented. It's the same. It's the same. A2L rated tools, they'll say A2L rated, A2L compatible, whatever. There's some key things that they're going to have a little bit differently, but most of it's stuff they've already had. It's like they're going to have, plastic coated or rubber coated connectors rather than having exposed connectors to prevent arc. But again, like in a vacuum pump, how much refrigerant are you going to be actually pulling through a vacuum pump? Like if you're pulling a lot of refrigerant through a vacuum pump, you're kind of doing something wrong anyway to even hit that lower flammability limit. So So recovery machines are kind of the big one. That's the time when you're handling a lot of refrigerant at that point. And again, we're not even at that point right now. Like we don't have the equipment yet, so recovery is going to be the thing that's going to be the biggest area where you want to make sure your recovery machines are definitely rated for the purpose. All right, a couple things. You cannot retrofit R410A with any A2L. There's not going to be any way to do it. It's not going to be allowed. It's going to be strictly forbidden. You will get a stern talking to from the EPA if you do it. They will put you in timeout. They will make you skip supper if you do it. It is not allowed. That really tickled Dre. Dre liked that one. Of all the really good jokes that I've told so far this morning, that's the one that got you. I mean, you just never know with some people. Leak sensors will be factory installed. Anything that's over 3.9 pounds of charge, so basically everything we work on. It's going to energize G, de-energize Y. That's it. So it's going to run the blower, going to deactivate the equipment, keep it from running. You're going to have red-capped service valves. Anything that could spark will need to be insulated. And again, this is from the factory stuff. I mean, I guess it could come up in the future if you're like swapping a capacitor or something and you're using a spade terminal. You would have to make sure that it's actually a coded terminal. So that sort of thing might come up. And it will, to some degree, that stuff will matter, not because of real life, but because of lawyers. Like, oh, the house burned down and you were there and you changed a capacitor and whatever. So. Sloppy stuff like taking a capacitor and just laying on its side or leaving it in the box or whatever. That kind of stuff is definitely not going to be okay with A2Ls because it does have a marginally higher flame risk. Striker plates. This is where it gets real interesting. Okay, so it isn't really. This is where the code gets really ambiguous. The issue isn't so much in the equipment, right? Because the condenser's outside. If there's a venting issue, it leaks, whatever, that's going to leak outside. If it leaks inside in the air handler, well, you have this mitigation, right? You have a sensor that's going to... But what happens if it's the line set, right? That's where it gets weird. Now, if it's in the chase, it's not that big of a deal, right? I mean, what's the odds you're going to have something that catches fire in the chase, whatever. But what if it's in a wall, or you have a line set in a wall, and then somebody comes in and hangs a picture and puts a nail through it? Now, that doesn't happen very much, but we have had a few cases, right, throughout roofing, generally speaking. Somebody does a roof and hits it on a ductless system or something like that. And that's where it gets a little weird. And so a striker plate or whatever you want to call it. What is another name for a striker plate or a strike plate? I'm trying to think of another. I know there is another name. I just can't remember what the people call it. But basically, it's this chunk of metal. It's a metal plate you put in that protects a line set. Anywhere that it's going to be close to drywall, that sort of thing, right? So potentially somebody comes in, puts a nail, puts a screw. It's not going to penetrate it. There probably are going to be some weird AHJs who are going to be like, well, I need you to prove to me that this existing line set in this wall or in this floor or whatever has proper strike plates in it. Now, the way that a lot of people are going to cover it is they're going to say, well, yeah, but it was built under the prior code, so you inspected it before, so it should have had it before. Realistically, were they always installed? No. Were they really checking for that? No. Is it really a major issue? Probably not, because even by the time that entire refrigerant charge leaks out, it's not like it's an unending charge. At some point, it runs out. So if it's 6 pounds, 7 pounds, 8 pounds, 9 pounds, 10 pounds, eventually it runs out. And so the odds that it's going to leak, and right at that moment in that wall, there's going to be a spark, and that's going to catch. I mean, it could happen, but it's pretty unrealistic. Now, where it becomes more of a concern are systems that have really big charges. So maybe like a multi-head ductless system or something like that, where there's much larger system charges, VRF, VRV systems, big commercial systems, that kind of thing. It becomes more of a concern. In residential, I really don't think it's going to be a thing, and I especially don't think it's going to be a thing in Florida. I think it's going to. It may come up other places, and it may come up. You may get a random inspector who's like, whatever. But as far as we know right now, there's not going to be any new requirements in terms of running new line sets or anything like that. It's going to be pretty much the same as what we've already had. This 10 feet or more working area thing is going to get discussed a lot. And the main idea is when you're working where you're actually working on the refrigerant system, so generally around the condenser. You want to make sure that you don't have flammable objects, and you don't. And this is where a lot of manufacturers are going to start making longer cords. So your recovery machines and your vacuum pumps are going to start coming with 10-foot cords. And the idea is that you keep them out of the 10-foot circle of trust or whatever. I mean, come on. I mean, it really. I have no words. So I mean, whatever. There may be certain job sites, certain situations where they'll make you put cones, to keep clients out of the 10-foot barrier, and when you're working on it, that may become a thing. But for now, it's just a recommendation. It's not a requirement that we're aware of. And again, at this point, OSHA, and this is what's so weird. This is what's super weird. Okay, like you would think. Sorry, I'm going to get political again. You would think that with something as big as a change of all the refrigerants that we use in the entire United States, in fact, the entire world, that they would have gotten together and been like, hey, OSHA, what do you guys think? Should we make consistent standard? Oh, yeah, let's discuss this. And then they would get together with the guys from NFPA, which is the Fire Protection Association, and they'd be like, hey, yeah, what do you think? And ASHRAE, their engineers would be over here, and the air conditioning contractors guys, they'd be over here, and they would all come to an agreement about what was going to happen and what the rules were. Nah, they just made the rules, and then they're like, we'll figure it out. We'll figure it out once people are already working on it. Then we'll make up the rules. And that's how they do things. So we have that going for us, which is nice. You are not going to need any new special PPE. You just need to wear the PPE that you're already supposed to be wearing. So your gloves, your eye protection. That's a huge one. That's one of the biggest ones. And you need to ensure adequate ventilation. So, have I ever told you guys the story about the motorroom that I was in where I actually learned about adequate ventilation? So I was working with a guy. I'm going to tell the really short version of this. I was working with a guy in this big house in Windermere that had 6 units, 6 air handlers in a closet. And I sent him down to pump down the system. And so at the time we had Nextels. Does anybody remember Nextels? Yeah, that thing. So I was like, hey, did you get you got it pumped down? Oh yeah, I got it pumped down. So I start cutting it loose, and I don't know if he pumped down the wrong unit. I don't know what he did, but I start cutting it loose, and psh, I'm like, oh, crap! It's a big motorroom, so it's really long, and I'm trying to remember. For some reason, I felt like it was adequately ventilated. Maybe I was just stupid. I don't know why. But the client was there. So I was like, just shut the door, shut the door. And he's like, well, it wasn't the whole thing. And it wasn't the entire system charge, but it was a decent amount of refrigerant. So I don't remember exactly why, what the situation was. But I remember, so he's talking to me, telling me some dumb story about something. And I remember all of a sudden, he's not making any sense. And then all of a sudden, everything's really funny. And he starts laughing. He's a great big guy, and he starts laughing. He's like, I don't, why is it? What is happening? He's like, I feel like I'm high, and so literally, I'm like, dude, trying to say something, and I can't form words, and so I just shove the door open, and I literally roll him out the door, and he's laying on the carpet just giggling. So it was pretty close. We were pretty close to passing out, and nobody would have found us in there. We would have just been giggling skeletons. So that has always mattered. Ventilation has always mattered. It becomes more important because in that case, if you got concentrations that were above the LFL and then there was a spark, it could actually ignite, and that would obviously be a problem. So ventilation matters now. The asphyxiation part, the displacing oxygen part, and the flammability part. Existing line sets, they can be used, just don't unsweat anything, right? You all caught on to the don't unsweat anything part, right? Don't apply torches to it, and even if you think you have it all out, doesn't matter, don't unsweat, because there's always some residual. You guys know this, right? There's some residual refrigerant that it gets entrained in the oil, and it doesn't all come out all at once. So you will be exposed to it, and you will see it. Purging, then flowing. Okay, so this is something that sometimes we miss, but we should be purging all of the air out and then flow. So you don't just set it at the real low setting. I'm just going to keep saying this and make sure you're all getting this. You don't just set it at the real low setting just to start. At first, you blow it through for a while. Doesn't take very long in residential, so it's not like something you have to do a big calculation for. I'm going to show you a calculator that we have created if you're doing like grocery stores or something like that. Those guys run into this. But for you, if you just do a quick with nitrogen, blow it through, blow it through, blow it through, done, then purge. Make sense?
This is something you should already be doing.
Correct. I'm just saying this like this is just always you should be doing this thing. And it really doesn't really matter for an installer because with an installer, the charge isn't even released yet, right? Like, so you're not dealing with refrigerant until you've released the charge, and so you almost never are going to have to face this as far as dealing with a system that currently has refrigerant in it as an installer. But you should be doing this anyway. You're trying to get all the air out, and then you're flowing just to keep it displaced as you're brazing. Everybody knows you're supposed to do that, right? Like you have to do that. This is like a non-optional thing that we require here. Okay, good. Why? Quickly, it's not the black flakes you see. Those don't come from your torch. Do you all know that? Like, so sometimes guys get confused. They're like they think it's something to do with their torch that makes the black on the pipe. What's happening is you're heating up the copper to a temperature where the copper actually begins to react with oxygen. And so that's what we call cupric oxide or copper oxide. So most common oxides we see are rust, right? So you know how steel turns into rust? It actually, like the steel itself, combines with oxygen and turns into rust. That's what's happening when you are heating copper. And so whatever you see on the outside, if you have oxygen on the inside, you're going to have that black crap on the inside too, which then ends up getting thrown into screens and filter dryers and expansion valves and all that kind of stuff. And we don't want that. That's no bueno. So we have to displace it. So we get it out of there. We get the oxygen out. We get the moisture out. And we do that by purging, then flowing nitrogen. Pretty simple. You all probably already knew that, I'm sure, but just wanted to make sure. We did create a nitrogen purge calculator. And what we realized was, because we had a case in a grocery store, this is just kind of fun fact knowledge. We had a situation in a grocery store where we know we were flowing nitrogen and we know we purged. And there was still a situation where somebody cut open a connector and they were like, look, I can still see a little bit of black in there. And we're like, well, the only problem is that when you've got like, miles of pipe, how long do you have to purge before all the oxygen's out? So we created a calculator to calculate how much you have to purge, depending on the length and depending on the size of the copper. So if you ever run into a big job, just know we created a calculator for it, because that's just how we do around here. You know what I mean? If there's a question, we hire somebody to answer it for us. And then we take credit. That's what you do. All right, so all it is with leak detection, all this stuff, it's just now more important. It's more required. Again, you don't want to leave a system leaking. We have to make sure that we're nitrogen pressurizing. We have to be 100% sure, because the risk is now greater. Now, like we said, is somebody's house going to burn down because we're using A2Ls and we left a leak? The answer is absolutely. Just kidding. It's just more likely that we're going to get blamed by some goofy lawyer, right? It's not a real reality, but we have to take a little bit more care to make sure that it matters, because that we're taking care of it, because you're also going to now run into clients. Now just imagine, okay, this hasn't happened yet, but it will happen. Bert's going to have to take these calls. Dre's going to have to take these calls. The client's going to find out that their refrigerant is now oh, this is that new flammable Freon, isn't it? This is the way people talk. Everything's still Freon. This is the new flammable Freon, isn't it? Oh man, well and they're going to get worried. And then when they find out that there was a leak, then they're going to get all freaky about it, and they're going to so we don't want to be the cause of leaks. If the manufacturer is, that's bad enough, but we don't want to be the cause of leaks. So we need to do the whole pressurization protocol, which generally the thing that we don't do great is we usually don't use quite enough pressure, and we usually don't wait quite long enough, right? We get a little impatient. So that's the whole reason why when you're doing your sequence of install, you want to get that thing brazed in, you want to get it under pressure as quickly as you possibly can, right? That should be like one of your first goals. Whatever you can do to get that sucker brazed in and under pressure, so that way you can hold the pressure test as long as possible. Because again, there's nothing more annoying than when you're already running behind, now you're like, I think it's dropping. And that's when you start like, well, did it really drop though? Like, it only dropped 3 PSI. That's not so bad, is it? Answer is yes, that is bad. It should drop exactly 0 PSI. And so things like making sure that whatever you're using for pressurization, that your seals are intact and like all that kind of stuff. And that's where I'm a fan of really reducing I talk a lot about this, but really reducing the number of connectors. So if you don't have to use a manifold, don't use a manifold. Just reduce down the number of connectors you're using, because it reduces the odds that you're going to have leak points that then make you really mad when you find out that you've been chasing a leak this whole time and it was just, you know, the gauge on top of your gauge set or something dumb, or the handle on the side. It's super annoying. You only have to do that 4,700 times before you realize it's not very fun. All right. This is all the stuff I already talked about. I'm not going to talk through each step of the test. Now, Bert is the king of when you're using soap bubbles. You know, he's very passionate about this. So go ahead, Bert. What are you looking for when you apply soap bubbles?
Okay. So
I just want to hear you say it.
Okay.
They probably already all heard it, but I want to hear it again.
We're looking.
No, go ahead. If you could go ahead and tell them, that would be great. Whenever you're ready.
We're looking for micro leaks. Okay, there you can find a leak with bubbles that you're not going to see in a pressure test for 3 hours. So just think about that.
He gave a pause for effect there. He's like, y'all believe that? You believe that? Because I'm telling you, it's true.
Because there's been too many times I've heard, yeah, well, the nitrogen test held, so I didn't think I needed to check that going with bubbles. But that's not true at all. We are doing both because we're looking for our faster drops and we're looking for the really slow leaks as well. And when you cover with bubbles, if any of you have not done this, take your little bubble spray, turn it around and read the directions. It's very clear on how to find the micro leaks. You coat it with a clean layer and then you let it sit 2 to 5 minutes, and then you can see the micro leaks start to form in that area. Whereas if you have a larger leak that you will catch on the pressure test, it's going to look like that within about 20 seconds. But if you have a micro leak, all you're going to see is a little white river of tiny bubbles. And initially, you're not really going to pick up anything, but you come back and now there's this little blob of white bubbles or a little line of white bubbles coming out. Clean that, spray again, another 5 minutes. See those white bubbles again? I have a leak here. And again, that one you're not going to see on your pressure test. So that's why we need to be doing both for all of our joints.
I'm not going to go over the full deep vacuum procedure. You all know our procedure on this. But you do need to pull a really deep vacuum. This is probably the second most dangerous thing with A2Ls. So the first is if you start applying a torch. But the second is if you leave massive amounts of air inside of a system that has a flammable refrigerant in it. Now, this is more for things like propane, okay? But if you've seen any of the videos, and a lot of them are on social media, of like there's like a guy in India like working on a condenser, and then next thing you know, there's no condenser and there's no guy and there's just a big hole in the roof. That happens because of something called diesel effect. And that occurs when you have a flammable refrigerant and you have a lot of oxygen inside the system under pressure. Okay, this is the only thing, because you know I bring this up a lot. Like, look, we're piping natural gas into people's houses all the time. Like, there's houses all over the place with natural gas, which is an unlimited supply of a very flammable substance, right? Like, that is a real fire hazard. Now, two differences. It's much lower pressure in that case, and it has an odorant in it, meaning you can smell it when it's leaking. In the cases of mildly flammable refrigerants, and then when we go to refrigerants like propane, they do not have an odorant added, so you're not going to smell it when it comes out.
I want to add this. If I could do leak detection again with my nose.
Right, back to the old days, yeah. And again, it's not, any odorant just isn't going to make, it's going to be a problem inside of a refrigerant system, like at least the ones that they've tested. So it causes sludge and that sort of thing. That's why they don't have it. So Bert would like it. I'll give that feedback to manufacturers. But this is the big issue, right? We do not want oxygen inside the system. And the way you keep oxygen out of the system is with deep vacuum. So it's not a step that you want to skip. Micron gauge, decay test, all that stuff that we've talked about. You have to follow that procedure. We're going to get to a point, and just get ready for it because it's coming, where we're going to have to start validating vacuum. So actually using screenshots, using workflows, all that kind of stuff. So you're going to have to prove it. If any of you are like, yeah, maybe I'm not always doing that, like, now's the time to make sure that you're doing it properly. Pulling cores, using big hoses. We like the for install. This is our method. This is still the way we're basically doing this, right?
Yeah.
Are you raising your hand?
Yeah.
Go ahead.
Yeah, I just want to say that when you are pulling a vacuum, and let's say you have a large leak somewhere, more than just pulling a good vacuum before we release charge, pulling a vacuum and walking away from something that's leaking is much more dangerous. So that's where that decay test lets you know if I have a leak somewhere in the system. So if I'm pulling a vacuum and there's a leak, a large leak in the line set, I'm pulling in oxygen into the system while it's running. And that's why my vacuum's not coming down. But I'm feeding it into the unit so that it's worse, that you do that decay test. Whereas if, let's say that you don't have a leak, but I only want to pull down to 1,000, and then my decay test held at 1,000, well, the good news there is you didn't introduce oxygen in that process. But when you're walking away from something that was leaking, that means that your vacuum actually pulled in oxygen.
Right.
Or you had that purged nitrogen in the lines, now it's worse. So that would be something.
Yeah, which further reiterates the reason why we have this like triple attack against leaks, right? You have nitrogen pressure test, so you're actually watching to make sure it's not dropping on pressure. You have soap bubbles to make sure that you don't have even micro leaks. You lay it on nice and flat and you look for those tiny little foamy bubbles, right? And then you have your decay test. If you do all three of those properly, you're not going to leave leaks. You're just not. Now again, this is where you can get really pedantic about it. Every system has like tiny leaks. Every system has like microscopic leaks in it that you're not going to account for, but we're talking about the ones that we're used to tracking, the ones you can see in soap bubbles, that kind of thing. And so the reason why that even matters is because those of you who are like, man, it's still decaying, like the number's still going up on vacuum. Yeah, it will, because there are still like these tiny microscopic leaks that are going to go. And when you're measuring things with a micron gauge, you are measuring a super tiny scale. Like you are measuring tiny changes in pressure, which is why you'll see things on a micron gauge that don't show up on a pressure gauge at all, which is why you have to use a micron gauge for vacuum, because you need to confirm that it's down at that really low level. The standard is pull it below or pull it to 500 microns and make sure it doesn't rise above 1,000 in 10 minutes. That comes from Carrier. That is not our standard though. That's the industry standard. Our standard is you pull it below 500 microns. I like to hit 300 and make sure that it doesn't decay above 500 within 5 to 10 minutes. That's a higher standard, a significantly higher standard. And so if it doesn't do that, that is what we consider to be a passing decay test. Non-condensables, this is one of my, this is just a side note. Dirt is not a non-condensable. So if somebody says, I think the system has non-condensables in it, and they mean a restriction, aren't the same thing. Non-condensables are nitrogen and air, things that don't condense, things that stay a vapor, right? So we don't want non-condensable gases left in the system, and that's why we pull a vacuum. Pulling a vacuum when all that's in there is nitrogen goes really fast. Pulling a vacuum when there's a bunch of air and water and other things in there doesn't go nearly as fast, which is another reason why doing all the nitrogen stuff that we already talked about is going to make your vacuums go lightning quick. It's when you don't follow good practices to begin with, maybe you're running line set and you don't have the ends capped or whatever, and that's when it becomes a real issue. But again, if you get dirt in the lines, that dirt isn't a non-condensable, it's dirt. Non-condensable is a gas, specifically nitrogen and air. Any questions about any of this? Jonathan.
Can we take H2O refrigerant and hook it to our grill at home in emergencies?
No, and it won't cook well at all.
It's not toxic.
Yeah.
Fine, whatever.
Jonathan.
So it's heavier than air.
Yes, it is a heavier than air gas.
Be watching out for in a confined space.
Yep.
The other thing is like for recommendations now, so all the new units are being recommended to be A2L.
All the new units that are coming out are going to be A2L. There is no.
Selling units now, we're not necessarily selling A2L.
We're not right now because the equipment's not actually available. This is another really fun thing about all this is like they mandated it before anybody even knew how to manufacture it. So it's kind of one of those cool, awesome things.
Whenever we get around to.
Yeah. At some point, industry, please change the so no, we're not. There's a few exceptions where you're going to see it. You're going to see some ductless units. especially Daikin ductless units, where you're going to see it. Daikin was kind of ahead of everybody else with R32 because R32 was already available. R32 was being used in Europe and Asia for the last 10 years. I mean, they've used it. They basically went straight from 22 to R32. They didn't have a 410A middle ground in these other places. So 32 is readily available. Daikin already pushed it into the U.S. market as soon as they made it legal. What was funny is A2Ls actually weren't even legal to use up until recently. Like, you couldn't even do it. In fact, the one that we have installed, the split system that's in the office up front, is technically a legal skunkworks project. You know, it's like we had to sign all kinds of waivers and stuff. Just silly. But you are going to start to see it kind of just slowly start to drip in. Carrier's likely going to be probably the next 3 to 4 months you're going to start seeing it. And so, yeah, again, it's just when product becomes available, and we don't know when that's going to be. One of the things that some people will ask is, well, what about storage? What about placarding? What about all that stuff? Seems to be, and again, this is all actually the fire code. It's not the EPA. It seems to be that they're not going to require anything special. You're not going to have to put flammable placards on the vans. You're not going to have to do anything super crazy in the shop, but there will be limits to how much of it you can keep in a single place without it being an issue. And so we may get to a place where we have to start storing the A2L refrigerants outside. There may be some stuff like that comes up. But again, just remember, it ain't propane. It's not, we're already handling big propane tanks, and that is actually flammable, like serious. This stuff is like just a little bit more flammable than what we've already been doing. Just keep repeating that. And that's what I would encourage you to tell clients as well. Like, this is mildly flammable. It's only slightly more flammable than what we were already using. It's just a slight change, not anything significant.
I think a lot of people mistake or can't differentiate between flammable and explosive. That's
Yeah.
probably the problem. They hear the word flammable and they think it's going to explode.
Yeah. And the truth is, almost anything's flammable. Most things are flammable, just a matter of temperature and flame propagation. Ryan.
Oh, what about like our micro gauges, like whenever we put them in R22 or 410, will they get damaged?
It won't be any different than what you currently face. The sensors.
I put mine on and it's working normal. I mean,
Yeah.
it can.
Yeah, that won't make a difference. I mean, again, like, a lot of guys will notice that if you expose your micron gauge to refrigerant, it goes all crazy. But that's just because it's calibrated. A micron gauge is calibrated based on the thermal properties of air and nitrogen, whereas air is mostly nitrogen anyway, right? So they're kind of the same. If you expose it to refrigerant, the micron gauge just goes all wonky because it's not calibrated to it. But as soon as there's no longer refrigerant on the sensor, it goes back to working fine again. And so it's not like it's something you have to clean out just because it gets a little bit of refrigerant in it. Now, what does happen to micron gauges is if you get oil in them. And that's why we recommend, because, you know, sometimes your vacuum pump will kind of, like, sometimes you leave a little pressure in and it'll hit your pump and then it'll kind of burp oil out and that kind of thing. And that's why we recommend, when you're doing micron gauges, and you see it in this picture here, you just kind of keep them pitched up so that in case even there is an event where maybe a little oil it's not going to run down in and hit the sensor. So in general, you just kind of try to keep your micron gauge elevated so that oil won't run down into it. If you get oil in your micron gauge, all you have to do is just use a little bit of alcohol. I think we say isopropyl alcohol, not Jack Daniels. Put a little bit in there with an eyedropper or something, and you just kind of tip it back and forth. You can also use like contact cleaner or other, you know, those little canned air, whatever. Just kind of blow it out. But oil on the sensor is usually what damages it. Now, there are some micron gauges that have a pressure limit to them. Which is what I like about BlueVac micron gauges, is they're designed to handle pretty high pressure. I think they're like up to 300 PSI, something like that. So releasing the charge onto your micron gauge, if it's a BlueVac, isn't going to hurt it. There are some brands that really aren't actually rated for that pressure. So anyway, do you have any opinions on that, Bert?
No, that's great.
Okay, cool. Tanner.
If any of our new systems are going to have like a larger charge.
No, they shouldn't have a larger charge. Depending on the refrigerant, charge size is going to vary a little bit, but it's going to be pretty consistent with what
I don't know when I've worked on something above 15 pounds.
Yeah, it's
Like 5 tons bigger?
yeah. Sometimes high efficiency 5 tons. Charge sizes have actually come back down again. There was a time where the way that they got SEER ratings was just making enormous condensers. You ran into some of these old train units that were like a house, and like, And that's how they got to efficiency. And so those had big charges. Nowadays, with our inverter-driven equipment, especially with the advent of, you're seeing more and more microchannel, you're going to have lower charge sizes. There's been a move in the industry to try to get charge sizes down.
Do we know anything about the infrared sensor inside the cabinets?
Do we know, we know what you just said. We know it's an infrared sensor. We know it's not going to sense like really fine leaks or anything. It's only going to sense if you have a high enough. It gets to a percentage where it potentially is a flammability risk. Do we know where? We don't know where it's located. We don't really know. I don't really know what it looks like. Again, like the stuff that I'm kind of feeding to you is like third hand. So there's the manufacturers and the EPA. Then there's people like Chemours who make the refrigerants, and ESCO, who are both organizations that I'm connected with who do a lot of this training. And so I'm essentially taking stuff that they've already told me and just recycling it. But it's not, it's possible that some of it is already out, but I haven't seen what they look like yet. Anyone else? Matt?
If just someone prefers, like right now, if they want to get an R32 system, would we be a Daikin distributor for them right now, or would we say that they need to wait?
We can get Daikin now. My experience is that most consumers aren't aware, and it's not like. See, the thing is, eventually the refrigerant will be more expensive. But it's not going to be that much more because the thing is just like we mentioned with 410A, the tanks are less expensive too. So like when you go to 32 and 434B, or 454B, now they have the spring actuated discs. The tanks are a little beefier, so you're paying for that in the price. It's not like it's going to be a significantly cheaper refrigerant. So there's not a great reason, honestly, to want to go to the new stuff. But yeah, if somebody asks for it, can we get it? Yeah, I think so. It's all a product availability thing. So, anyone else?
Tell customers that this new refrigerant is less flammable than their hair.
I just don't know if that's true or not.
Well, perfect. That's why it's so safe.
If what you could do to make it that way, though, is you could spray some like highly flammable hairspray in their hair first, and then say now it's definitely less flammable than your hair. Right. Cool. All right. Thanks for all the good questions. Appreciate y'all. Thank you.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.